Hello. Don't know if anybody's there. I forgot to pull up my stream. Is this the one live? This is the one. Not the screen I want. There we go. There we go. Now I can see my live stream. It's just me right now. Hopefully we get some people to join in shortly. Just checking Discord. Got people saying they're going to join me. There we go. We got somebody. Hello. Don't know who's there. All right. Just picking up where we left off last time. Oh, good. There's all the code for the JWT token, the JSON tokens. And let's see. I found this. Put that over there. This will help us work through using JWTs with Fast API. Interesting. All right. Okay. Let's get this party started, I guess. Hopefully I sound all right. Can't hear myself for some reason. I forgot to check into why that wasn't working last time. Probably can do this. Let's just pull it up here real quick. Yeah, there we go. Yep, audio's working. Okay. So where were we? All right. I guess I'll just pull up that article real quick. Basically what we're just trying to do is we're trying to add a way to use JWT JSON web tokens to secure our API for our little code sharing service. And so like what I need to do is figure out how exactly we're going to secure API endpoints with Fast API. Like Fast API has a mechanism for doing security on a route. I'm just not totally sure how that works. So that's what we got to figure out. Do I have the server running right now? Doesn't look like we do. Trying to think. Poetry. Run. Did we have dash server? No module named server. All right, so why do we not have a module named server? Let's go into here. No module named server. Oh, that might be the other project. Oh, we haven't created it yet. Okay, I see. That would make a lot more sense, wouldn't it? Right? Or do we have it in main? Okay. So what's happening is I'm grabbing the command from the other project that we've been working on. So if I do, we need to move up a directory actually. There we go. And then we can do poetry run and not server bit. So there we go. Something exploded. Something exploded in the site.py file. This one right here. Aha. Yes. Let's just do that for now. I did not mean to do that. Now if we run it, yay, we're running on there. It's localhost 8000. This is one of the nice little features of Fast API. It automatically comes with all of this built in. Validation error. I don't know. All right, so we have list and we have create, but they haven't been set up to do anything yet. They're not secured. So now we got to figure out how to do that. All right. Alrighty. Okay. So then this is just walking us through setting up a Fast API website. Let's see. And now we're getting into the authentication bit. This is where things start to get interesting. So we're just going to, really simple, but all we're gonna do right now is implement the necessary bits to make it work. And then we'll figure out how to adjust it to work the way we want it to work. So like, I'm just gonna go with the most basic JWTs. I want to use asymmetric keys where I have a public and a private key. I think this tutorial is going to walk us through using a symmetric key token, which is just going to have one secret that if you know the secret, you can decode the token, you can verify the token, and if you have that secret, you can create a token. So the same secret is used for creating and verifying a token. The reason why I want to use asymmetric is so that only the web server can create a token, because only the web server has the private key. But anybody can verify a token was created by the server so long as they have the public key. And so that's why I want to use asymmetric, something like RSA, because then you know that you can share your public key without the risk of someone using that public key to impersonate you. And so that's the danger in using a symmetric key encryption system, because when you share that secret, and that's why we call it a secret, because it should be kept secret, but when you share that, anybody can sign something, can encrypt something, and it'll look just like your server did it. So, and that's why I want to use asymmetric. So we're just going to go through this real quick. And we're just going to use some basic stuff. The basics, the absolute basics from this. Just going to copy this out. We're just going to drop all the little functions they've got in their tutorial right here in this file. I'm on a later version of Python. I know I can just do that. They want us to grab, like, they're using like this decouple module and all that fun stuff to pull in stuff using a config system. We're just gonna go with the most basic implementation. We're just gonna do stuff like this: secret, and then algorithm, and like down here they list off they're gonna use this algorithm right here. So we're just gonna drop that in right there. And like here they're showing, like, if you were to use this symmetric key system, which is perfectly fine, like if you control your front end, if you, or not the front end, you would never use a symmetric key with the front end because of the reasons I said. Because anything you put on the front end, anybody can access. Like, you're literally, so anything on your front end is getting sent to the client. And anything being sent to the client, you're losing control of. They can do whatever they want with what you send to them. There's pretty much no way you can guarantee the security of anything you send to the client. So there is where you would want to use like an asymmetric system for sure, because you don't want to be putting secrets on the front end. But like if you have a Discord bot and you have a website and they're each running on your own server, like maybe you have two different servers up, you got one that's running a Discord bot, one's running a website, and you want them to be able to talk, and you want them to be able to talk securely, you can do that using a symmetric key encryption. So like just where you have a secret, and it'll be perfectly fine because you control both ends of that communication. And so long as the secret never gets sent across, anybody observing won't be able to decrypt what you're doing. So it's perfectly fine in those cases. Anytime you control both ends of the communication, it's perfectly fine. I want to make this using asymmetric because I want to be able to just drop a public key into a GitHub repository and not have to think about secrets at all. I don't want, because like I want to have my Discord bot be open source, be public, and let anybody use it and not have to worry about secrets and all that fun stuff. There might come a time where I need to change some stuff about that. We'll see. We'll see how that works out. And that's the thing. Because I'm going to be using a public key system, there might come, like, I might need to change it because anybody with the public key I'm not going to be able to, I'm trying to think. We'll cross that bridge when we get there. All right. So then we need to import time. That's the next thing. Just getting this code here integrated into our script. And then we need to import JWT. Last week we installed PyJWT, so we've already got that installed. All right, and this one is using PyJWT. It's not using, I think it was PyJose is the one that Fast API shows in their docs. That one's a little more oriented towards using Google App Engine. I'm not using Google App Engines. I don't necessarily need something tailored to that. I don't know all the differences, but it's definitely possible to just use the regular old PyJWT package. All right, so we have the signed JWT. Now it's complaining because it doesn't like the way they are formatting their function names. So I'm just going to rename that so it stops complaining. All right. On here, it's just telling us what this is doing right here. It's just creating a payload. And that payload is then being encoded into the into a JWT token. Right here, that's what that payload is. And then the JWT secret is what we have right up here. It's using this secret. And since this is since it's symmetric, that is our secret key. That's what we're using to encrypt and decrypt the token. And then here is our algorithm, and we've defined the algorithm as this HS256. That's a secure, fairly standard symmetric key encryption algorithm. And then here we have the decode JWT. So let's just copy that. So we have sign, and then we have decode, and that's the important thing here. We're not actually encrypting anything inside this token. The only thing we're doing is we're taking this payload and then we're creating a signature using the algorithm. I'm not totally sure. I haven't looked at the exact specifics on how JWTs create that signature. My guess is they might just be taking the JSON string from the payload, because that's what the payload is. The payload is going to be a JSON string, and then it's going to be B64 encoded, which is just a fancy way, a simple way to get some basic compression and to make things URL safe, because it uses 64 characters that are URL safe. So yeah. But I'm not totally sure what they're passing to the encryption algorithm for the signature. But all it's doing is it's taking whatever that is. It's gonna be somehow the payload. I think it's gonna be the payload B64 encoded. That's what I think it's doing, just for efficiency's sake. And then it signs that. And basically what a signature is it just takes that thing and it encodes it. It might encode the hash. I think it's encoding the hash. I'm just pulling stuff from the back of my brain here. I think it hashes it and then it encrypts that hash. All right. So then what you can do later on is you can take that signature and you can then hash using the same algorithm. You can hash the payload, your B64 encoded payload, and you can compare that when encrypted with the signature. And that'll tell you if the payload has been modified, because if that hashed and encrypted payload that you just created doesn't match the payload, the signature, you know they're different. Something has changed in between. So, and that's how JWTs work. They literally send the data. If you watch last week's stream, I show how you can actually access the data in the JWT token without doing anything with encryption. You just have to B64 decode it. It's as simple as that. And you can see all the data that's there. All that the token is doing is saying, hey, here's some data, and here's a signature I created from that data. And because all of this, the algorithms are public knowledge, and we are communicating which algorithms we're using, that's in the JWT, it's also B64 encoded. All that information is right there. So you know then how you can yourself encrypt the payload to generate the secret or the signature, and then you compare it with the signature that's included in the token, and now you know that data either is valid or invalid, if it matches the signature or if it doesn't match the signature. So you can get an idea of whether or not your data has been tampered with. And that's the whole idea here. It's just a way for you to send data to the client, which you don't control, and they can do whatever they want. It allows you to send data to the client, and then the client to send that data back to the server, and you know they haven't tampered with the data. So you can pass down a user ID, and you can pass down some user roles, and you can pass down some user information, and then you can have it send back that information, and you know it hasn't been tampered with. And that allows you to authenticate. And like the reason why this is valuable, and the reason why we might want to use a JWT over like a PHP session ID, which is just an ID number. Like the difference here is the JWT lets you send user data down and then back, so you don't have to go back to your database to find out who it is. If you just have a session ID, when the client communicates with your server and you check the cookies and you find that session ID, you've got to go to your database and you've got to look up who got that session ID. Who does that session ID belong to get all the user information? So the JWT is just eliminating the need for that database request for you to go back to your database and look up any information. You've already got your user ID. It's going to be inside your JWT. You can put the user roles in your JWT. And now if you need to know the user's roles in JavaScript for your React front end, you have that information. And then when that token is used to authenticate later with your backend microservices, it's already got the user ID. It's already got the user roles. So it knows that those are valid because it's got the correct signature. So you can literally skip that request to your database because you've got your JWT. Now, there are some issues that come with this because how you can't invalidate a JWT. And there are some ways to get around that. Maybe one of these days we'll touch on that. Maybe later on in this project we might mess with that. But so there's a trade-off that when you send this data, you have no way to revoke what's been sent. It's already been sent. They have all that information. If anything changes, they don't get those changes because it's all on the client now. So we're going to eventually have to add in mechanisms that allow us to update the client when necessary and to verify that the client has valid data. So that's something we'll get to later. Right now, we're just going to work on implementing a system that uses JWTs. All right. I feel like there's a proper way to pronounce JWT, and I've known what it was in the past, and like right now, I just don't know what it is. Like it's not coming to my brain. All right. Now here we're decoding, and like we see like right here, he describes how all this is done. I'll put this article in the description. Here, let me just do that right now. Let me put that in the description. Can I do that from here? Can I edit this from here? Edit title and description. Yeah. All right. References. All right. All right. So that should show up in the description now for anyone who's here. All right. So next up, I'm just going through this here. So basically he describes what's going on. The decoded token. So like we're just taking the JWT that we got, the token, and we're going to use the same secret like that we used to encode, and then we're going to use the same algorithm that we used to encode. We're going to on it, and that'll give us back the decoded token. Now, I feel like I don't know exactly how the JWT. I think that JWT decode. Oh, okay, that's right. He's got this except here. I don't like that a super lot. Just trying to jump in here and see if I can figure out what it will raise, because I don't like how that except raise invalid string. So we're using a decode error. Just trying to see here. I think is it just decoder? Okay, validate claims. We get a type error. Okay, so we just get a decode error. Seems a little odd. Must be an integer. There's a lot of different errors in here that this thing can raise. So that might be why he just went with a blank exception to accept everything. I'm not a huge fan of that. I would prefer a different way, but I can see, like, we're just looking through this decode method, like, there's a lot of error messages getting raised. Back to there. Like, just this one right here is raising a decode error. Decode error. Then it's calling validate claims, which is can raise a type error. And then it's calling like required claims, which is right down here, and it can raise a missing required claim error. And then it's using, like, depending on a bunch of different things here. It calls different kinds of methods, and it'll do like valid issuer, decode error, image signature error, decode error, expired signature error, invalid audience error, missing required claim error. Like, do these inherit from invalid token error? So, like, we could catch like an invalid token error, because, like, you see all of these are inheriting from there, with the exception of like this invalid key error. But we could inherit from this one, which is their base class for all of their exceptions. And, like, I try to do this. I'm not super great at making sure I always do this. But if you have a package that you're intending for people to use, it probably makes sense to have just like a base exception type for your package so that you can just catch all of them. And I think I'm going, let's see what files, JWT exceptions, invalid token error. So I think I'm just going to inherit that, or import that. If we can find the right file here, we're just going to do JWT dot invalid token error. Yes, it is in the top level package. All right, cool. So if there's anything wrong with the token, we're going to return an empty dictionary. There was no data found in the token. But if the token is fine, it will check if it has expired and then return it. I'm not going to use that, I don't think, for now anyway. We'll see what we do later. Like, at some point, I've got to add an authentication mechanism to this. And that will need to be secret somehow. I'm not sure how we'll figure that out, how we'll do that just yet. Yeah, we'll figure it out, like, step by step, one thing at a time. We'll get there eventually. Like, at some point, I might actually create a system for creating a JWT that you can use to access the API, and then it'll use a public private key to verify that JWT. For now, I'm just going to rely on the public and private keys to just generate JWTs willy-nilly. It's not secure. Like, that's not going to give me any control over who accesses the API. But it implements a basic system that lets me do it. But yeah, so we're decoding the token. We're using the token we're getting. We're using the secret we created the token with. We're using the algorithm we created the token with. If this function right here raises an invalid token error, we send back an empty dictionary. The token was invalid. No data was found that was usable. So we just send back an empty dictionary. If the token was decoded successfully, we're going to check the expires key, and we're going to make sure that that expires key, the expires value, is a time in the future, not a time in the past. That's what's happening here. So like basically we're just saying this token is going to expire at such and such time in the future. Don't honor it after that point. Now, in that case, if it is expired, it returns none. That seems really odd to me. I'm not sure if there's a reason for that. So we'll just keep working through this. And at a later date, we'll make a judgment call on that. I feel like it should return an empty dictionary in that case, because it's technically an invalid token. We'll figure it out, though. We'll come to a conclusion at some point. Like, I might change this to something like if decoded token expires, it doesn't have autocomplete in the keys. I need to find out if there's a way to do that. That time is greater. If it's greater than, then we return the decoded token. If not, like this is what I might change it to. We'll just pass. And then we'll have down here, return empty dict. And so then, only if the token hasn't expired and is valid will it return the token. Otherwise, it's just going to return an empty dictionary. But for the moment, we're not going to do that. We're going to just leave it the way it was. Right like that. And we'll just let it return none. I do feel like it should be an empty dict, though. Yeah, and like right here, he's talking about like how exactly the JWT works. He's saying like a JWT is not encrypted. It's base 64 encoded and signed. So anyone can decode the token, use its data, but only the server can verify its authenticity using the JWT secret. So that's what I was saying. It's like you literally have that data in the token, publicly accessible and visible. Anybody can read it. They just need to know how. And they don't need anything crazy. They just need to be able to base 64 decode. And like if you're on Linux, there's a command line utility for that I think comes built in with just about every Linux distro. You can literally just drop in some base 64 text, decode it, and it'll show you the output. So they're not secure if you have anything you don't want anybody else to have access to. So be very aware of what you put in there. You don't want to be putting a password hash in there. You don't want to be putting a password in there. I don't know why you would have a password, just a raw password, but you definitely don't want to put it inside a JWT. Bad news if you do that. All right. Add the user schema. So here he's just creating some schemas for his API. And like here he's importing this function right here. So whenever we see signed JWT, that's going to be our function right here. The one that encodes the payload. The payload is just going to be a user ID with the expiration time, which is going to be 10 minutes in the future. So you get a token that lasts for 10 minutes. Add the user registration route. So he's adding the route. And you see how like right here on the route, he's signing the token with the user email. So his user ID is literally just going to be the user email. All right. An email validator. I don't think I'm going to need to install that. We're just going to be adapting this very basically to work with our system. And like right here, he's saying, make sure you use bcrypt or passlib before saving the user's password to the database. Like, you don't want to be storing the raw password in your database. You want to be storing a hash of that password. And then you hash when they log in. You hash that password they give you, and you compare the hashes. That's like industry standard. It's how you do it. I did a very simple, very basic hashing algorithm that you should never use in production on my other stream series that I've been doing on Sundays, where we're building a... What are we building? We're building a... Oh my gosh. We're building a cloud file storage service that you can run on your own computer and store files on that computer that you're sending over an API, also using Fast API. We need to get authentication working there as well. So these two series are kind of working in tandem here, but I did already implement a password hashing algorithm. Very basic, rudimentary, only use it on your own private projects kind of thing. Never on a public project, but like, just, I did it that way to give you an idea, to give people an idea of how you would hash passwords. Because it can kind of be a little bit black box, a bit of a black box using bcrypt or passlib. It's just, here's a password, deal with it. So I built a very simple hashing function for it to give people an idea of what's happening behind the scenes. All right. So next up, he's creating his check user password thing. I think he's just storing users globally. I'm not sure. This is a very basic system he's building here. I don't know where it went. Yeah, right here. Here's his users list. Then if we come back down here, he's got his schema, and then he's got, where the API? He's got this little check user function. He's literally looping through that global users list, and then checking their email and checking their password. And like, he's just storing the raw passwords. There's no hashing happening here. So he's just comparing them to one another. And like I said, not a great idea. He also pointed that out, so. All right. And now he's defining his login route. It's calling that check user function he has right here. And then if the user is valid, because he has his user login schema, if the user is valid, he signs the user ID. That's this function right here, and that's going to return the payload as a token. And the token response function is literally just creating this dictionary right here, with access token is the token. And that's what's going to be sent back in the body of this user login API endpoint. So that's going to return a JSON dictionary. Can we see that? Kind of. Yeah, here we go. Like, see right here. This is the response from his API endpoint. It's going to return an access token, a dictionary with the access token key, and then as the value, there is his HS256 encoded, or signed JWT. It's all B64 encoded. The first section is the information about how the token was created. The second section is that payload. It's just the JSON data. It's just literally this right here. Let's see if we scroll back up, make that smaller. It's literally user email saying GWD. That's gonna be in this one right here. It's literally just this right here. That bit in the token. If I could get the thing to zoom in, there we go. Gotta focus Chrome. This section here, starting at this period and running over to here, is just the B64 encoded JSON object for this dictionary right here. So it's going to have the user ID key. It's going to have the user ID, which is their email. It's going to have the expires key, and that's going to be an integer of the current timestamp plus 600, so 10 minutes. So it'll be 10 minutes in the future, the timestamp for 10 minutes in the future. And that's all that's going on. All of that's inside this section right here. And then this last section right here is the HS-256 signature for this payload right here. And I think it might even include this part of the payload as well, that describes how it was created. And the reason for that is, the reason I think that is so that you can't modify this bit right here and try some trickery to get the backend to falsely verify. So yeah, I think the signature is covering both sections before it. It might just be the payload, but I'm pretty sure it's both sections before it. And like I said, I'm pulling a lot of this from the back of my brain. I haven't looked at how JWTs work under the hood in a long time. All right, so now we're moving on to, now we've seen what's happening. We're seeing how that login works. We're seeing how all this functions. Now we're moving on to actually securing a route. How do we use all of these functions that we've created here? This decode JWT, the sign JWT, and then this token response function. How do we use those to create a route that is secured? A route that requires you to have a valid signed token in your request. And so that's what we're getting into now. He's going to be using a Jwt Bearer. A bearer token is just saying when you make a request to an API, it will have a bearer header, and that header value will be your access token. And so you are a bearer of a valid token, is basically what it's saying there. So that's what he's using. He's building his own Jwt Bearer class, and he's inheriting from the HTTP Bearer class, which is part of the Fast API security package. It's right there. And so like he's going in here and like he describes this all below. Like he has init, call, verify, explains what each of these functions do. Right here, he's setting it up to auto error. I believe that's just so that like if it fails, it'll give an error message. And he's defaulting that to true. So you could disable that if you want, when you create an instance of this class. And then right here we have his async call function. And all that's doing is, what is this doing? Let's see. It's creating apparently it's creating the authorization credentials. I'm trying to see super Jwt Bearer. It's just calling super on this class. So that class right there, when you call it, it's going to return a credentials object. And what I think that's doing is it's looking for the headers that you need. It's like we're talking about the scheme for the credentials. So if the credentials are found, then we're going to check if the credentials scheme. I'm not sure why he has done it this way. If not credentials.scheme equals bearer, I personally would do credentials.scheme bang equals bearer, so you don't have to put the not there. I feel like the not is a little extra. It might be. I guess it would be easier to just scan the lines and see this is a not. We're not equals. I've never found that I've skipped the bang, like the bang stands out. And like I've got my little fancy Fira code on here, which does the strike through on the equals when I do that. So it jumps out a little more to me, I think, there. But yeah, that's an entirely valid way of doing it. If you want to use the not and then the double equals for equality checking, that works. All right. So like if the schema is wrong, if the scheme is wrong, if it's not a bearer scheme, we're going to status code 403. 403 is forbidden. So you have 404 not found, and you have 403 forbidden. invalid authentication scheme. And then we have verify JWT, which is down here. He's got self.verify JWT. And that just checks if is the token valid, false, try, payload, decode, JWT, which is our function right over here. If that returns, this is actually interesting. So it gets the payload. It'll set the payload to none. If the payload exists, it'll say is token valid, true, and then it'll return true. I'm trying to see. I feel like this is a little bit wordy. This probably could be condensed down to be a little bit more concise. It works. It makes sense. I can understand what it's doing. It's valid code. It's a perfectly acceptable way of doing it. It might be a little bit easier to understand what it's doing just at a glance this way. All right. So yeah, he's just doing the verify, and if not verify JWT, and we're passing in the credentials, so it's getting it's credentials, not credentials. So that is going to be whatever the value of the bearer token is. And so that's passing into the verify JWT. So the JWT gets that and then verifies it. And then if it's not valid, if it's not verified, we're going to do an HTTP exception. And once again, we're doing 403 forbidden, invalid token, or expired token. And so like that tells me right there, because he's just checking if the payload, we could totally do like I said before and just return an empty dict and not have this random none in here. So I will probably rewrite that all to use that setup instead. I will probably also rewrite this to use an else rather than all of this inside the try. Like you want to just have one line inside your try if you possibly can, just to avoid accidentally catching exceptions in other parts of your code that you didn't expect to happen. You want to know about that. And if it's inside an exception block, a try block, you might catch that exception and you won't see it, and you're going to be very confused why your code is behaving the way it is. All right. So he's raising these exceptions. If the credential scheme is bearer, if the token verifies correctly, then we're going to return credentials.credentials. So we're going to return, interestingly enough, we're going to return the token. We're not going to verify it anyway. We're not going to return the extracted token values. We're just going to return the token. If no credentials are found, we're going to raise a 403 forbidden. Like, I feel like I'm not going to critique the code. Like, we're just going through the code here. We're just going through to understand how it works. I was just going to say, like, I probably would have moved this to the top. If not credentials, exception 403. So this way all your 403s are in a row, and then you end it with your credentials.credentials return. Just how I would organize it, but I'm going to stop critiquing the code because that's not why we're here right now. But yeah, so if the credentials were invalid, if there were no valid credentials found, if the token wasn't found in the headers, we're going to 403 forbidden, invalid authorization token. I think I probably reword that to authentication token not found, because that's why credentials is empty. All right, so we're just moving on, and he explains all of what's happening right there. And then he's going to talk about dependency injection. He lightly touches on this. He doesn't touch on it a lot. He touches on it some. Basically just shows how to use it. So we're just he had all these stuff in different files. I'm just dropping it in one file for now. Later on, I'm probably going to split it out. I'm just trying to get this working, so I'm just dropping it all in one file. He's importing them. He's importing his schemas, and then he's creating his routes. I'm going to adapt this to my thing in a minute here. So basically, he has his Jwt Bearer class, which we need to come up here. We should copy that. We need to copy all of this, and we need to drop it in here, right, like that. And then we need to do fast API from fast API dot security import. What's the first thing? HTTP bearer, and then we need to import HTTP authorization credentials, and we need to import request from fast API, right, like that. And then we need to import HTTP exception, right, like that. And then we need to rename this because we renamed our function, right, like that. And they're doing that thing again where they're just catching all of the exceptions. And I don't think, yeah, we're not propagating any exceptions. We're not propagating any exceptions. So if an exception happened, I would want to know about it. So I'm just going to remove this, right, like this. Just while we're here so we can see it. And then I'm going to do this. I'm going to rewrite this code. Return. This one right here is going to return true. I like that. And this one's going to return false. And like we can condense this even further because we can do, because all we care about is verifying it, right? So we can return bool, right, like that. And now we've simplified that a lot. All right, there we go. Why is it complaining? Maybe static. Okay. I don't actually care about that. That's whatever. There. Make that a little bit cleaner. I'm probably going to end up reusing this code. So, all right. Next up. So we've got the class. And then we have the dependency injection. So we're going down here. And then right here is where he's adding in support. So we need to import depends from here. From fast API, we need to import depends. And then we're going to tell the fast API that our route depends on our Jwt Bearer class. So that's just telling fast API that our route is going to use this Jwt Bearer class we've created to verify whether or not the request is valid. And basically what's going to happen, I think what is basically happening here is, whoops, we forgot something right here. Depends. So basically what I think is happening here is fast API is going to go through this dependencies list here every time this route is called, is run, and it's going to call each of these dependencies. Now what this is going to do is this is going to make sure that everybody is using the same instance of the Jwt Bearer. So that's why we're using depends there. I'm not sure if it matters or not for our case, because nowhere inside of our Jwt Bearer security class are we ever looking at the state of the application. So for one run of the application and the next run of the application, or one request and the next request, it doesn't matter what's going on. Because we're not checking the state. We could create a new instance of Jwt Bearer every time, and it would function exactly the same. So I'm not sure if we actually need this depends. That might be a fast API thing. I'm not sure. We could experiment with it later once we get this working and we know everything is functioning. But for now, I think we're good. I think that's good enough right there. Okay. So now we have our list all bits, and we're telling it we're dependent on the Jwt Bearer. All right. So now if we go to our docs and let's restart this. restart that. Okay, UV Corin is running, and then we come over here, and nothing changed. All right, did we do something wrong? Because if we look at the docs here, he says, all right, depends. Oh, I see. All right, we had to do this, right, like that. Okay, and then if we restart our server, and then we come over here and reload. Aha! There we go. Now we've got our little lock, and we can set our token right there. Close. And so like now we have like this authorized button and everything. So now this route is probably secure. I haven't tested it yet. We will find out shortly. First off, we need to get a signed JWT. So how are we going to do that? Let's do at app.get /v1/API/authenticate. And for now, we're going to just do really basic authenticate. We're not going to do anything crazy. Return sign JWT is all we have to do. And we're just going to do 0 right like that. And that was expecting a string, wasn't it? So we'll just send a string in. Bob. All right, so now we're going to pass that in for Bob. And then if I come over here, let's restart this. I don't have the auto reload turned on because I can't get logging to work with it correctly. I'm so not worrying about it. All right, let's try this out. Execute. Now, does it? You see what I did wrong? I forgot to put a slash. There we go. So now we got to restart and retry. Let's retry that. So let's go over here to authenticate, try it out, execute. And like this is what's great about Fast API. All of this stuff that I'm showing you right here comes for free. As soon as I create a route, it shows up, it creates this docs route, and it shows up, it shows the list of every single route that I've created. And I can click on any of them, and I can click on try them out, and then I can execute them, and I can see, and like I can set all the parameters and everything in here to see what's going on. And then so like you see right here is our access token. All right. And then I can come up here and I can go to authorize and I can put this access token right there, authorize, close this. And then we can come over here to list. And this list is just going to return, it's going to do logger.debug testing. And then it's going to send back a bits with an empty list. And so then if we click like try it out, I have limit, it's defaulting to -1. We can execute that. And you see right there, it returned bits with an empty list. So that's working. And if I were to come up here and I was to log out and then close that, I can try it again. Let's clear this and let's execute. And then I come down here and it says detail not authenticated. So I can now generate a JWT that lets me securely right now, anybody can create a JWT, and it'll always be for Bob. So it'll always be the same JWT, but it lets us authenticate securely with our list API just by doing this right here. It's a bit cumbersome to have to do this on every single route. I'm not sure if there might be a simpler way to do that. That's something to look into. But it's working and we've got it doing the thing we want it to do. So now in the future, let me see, do I have that still open? I do. Now we're all set. We're ready to go to use this code that we used yesterday to create a private key and a public key and use those to generate our tokens. So this way, like I said, we can share that public key with everybody, and anybody who has that public key will be able to verify that the JWT was generated by our server. So it'll be a really cool system. It'll be really great. It'll be really awesome. And like this is going to be using RS256. Instead of HS. The difference being the HS256 is symmetric. It just uses one secret. You have to share that secret with anybody who needs to be able to verify the token. And that means anybody who needs to be able to verify a token can also create a token. So they could modify the token and then send that back up, and it'll look valid because they have the secret which is necessary to create the token, which is why I don't want to use that. Using the public private key with RS256 here, that lets me have that private key and that public key, and only the person with the private key can create a JWT token, and anybody with the public key can verify that that token is valid, but they can't modify it. They can't create a new token. And that's where asymmetric differs from symmetric. And you've got to know what you're looking at, what you're dealing with, so that you know which one you need to use. And I do want to make this system, this little file, this code sharing site, accessible to anybody who wants to use it and make stuff that works with it, because who knows what we might do with it in the future. So I want to have a safe system that allows anybody to access it and work with it and deal with it without compromising our security. So we'll get to all this later. I'm probably going to end up thinking about exactly how I want to organize all of this. But this was a good little article. I had a few little nitpicks. I'm a little bit pedantic about my code. I like my code to be formatted a very specific way. And I can get caught in the weeds nitpicking other people's code sometimes. Maybe I should do a stream where I nitpick your code, all of y'all's code, because that might be fun. Just roast your code, I guess. We'll see one of these days. But like this article, if you want to go through it and deal with it and look at it, is in the description for this stream. And it's a really good article. Nitpicks aside, it's a really good article. It's well done. It's easy to follow. It explains the things you need to understand. It doesn't get caught in the weeds, diving down rabbit holes. It just is like, hey, this is what you need to use, and this is how you got to do it. And it helps you get to a working product using JWTs to secure your routes. And like I said, at some point, I'm going to need to create a way. Like, I want to make a system where, like I said, anybody can access this API. But the trick is, I don't want to just let anybody access the API willy-nilly, because then it might get abused. I don't want to allow someone to just abuse the API. If someone's doing something bad with the API, I want to be able to prevent them from accessing the API. I want to make it hard for them to just automate everything. So there may be what I'm probably going to end up doing is creating a system with, like, this is going to have a front end. So in the future, I will probably put an account page that you can go to. And it's going to be, you're going to be able to log into this using your Discord account. That's the idea. We're going to be using OAuth 2 with Discord to log in. And so I will probably add an account page where you will be able to get your JWT. So instead of having this authenticate route, this will probably still exist. But it will be limited like to a specific user, and that user will be the website front end. And actually, no, never mind. It won't even be like that. It'll just be whatever route is handling creation of that is showing the profile information, the account information that shows the form where you apply for your API access. That will handle generating the JWT securely, and then I will know who the user is, and if they are abusing the API, I can revoke their token and prevent them from getting a new token, and then the whole API will be safe. And that's why we're doing this. That's why we're building this into the API, and that's why it's a little fuzzy right now how it's going to function. A little fuzzy for me right now how it's going to function, because I just know vaguely in the future what I want it to be able to be like, what I want it to, how I want it to work, and that informs what I'm doing now. So I'm just kind of working on a vibe right now. This is how I want this to function, how do I want it to work in the future. This is how I want it to feel. This is how the basics of how I want this whole website to feel to the end user. How are they going to interact with it? And now I'm building out all the little pieces that allow me to have a website that feels and functions the way I want it to feel and function for the end user. So basically, when this is done, anybody will be able to access the API, but I will have the ability to block access to anybody who's using the API, and anybody using the API will have to have a JWT that has been signed by the server. And they will be able to verify that that token is actually signed by the server and not just signed by anybody. So it'll protect against like man-in-the-middle attacks and that kind of stuff, where someone might try to do something weird. I don't know why they would, but I just want to be on the safe side. So that's why I'm doing this. We could do our own little password system, but this adds in a lot of technology and functionality that would be hard to build ourselves. We could totally build our own encryption system using PyCrypto, or not PyCrypto. What was the package? Come back over here. PyCryptography. The cryptography package. That's entirely possible. You can access the RSA algorithm directly from the cryptography package. And you can use that directly yourself. But then you have to understand how everything works, and you have to make sure that you're not doing something that leaves a hole in your security that makes you vulnerable. And just using PyJWT and the JWT package, using the JWT spec, that ensures that you have technology in place that is safe and secure and is going to function how you expect. And if there's ever an issue with it, you don't have to change anything in your code. You just have to update PyJWT and you get all of that those security changes. So yeah, it's that's why I'm doing it. And that's why I'm walking through this, and that's why I'm going through this. And I'm a little bit, I like to talk. I like to dig into this stuff, and like I like to explain it and make sure that what I'm saying makes sense. So if anybody has any questions, like my Twitter is in the description. You can find me on the Beginner.Code's Discord. If you have any questions, just ask me, let me know. Like I'm sometimes monitor my YouTube comments. I don't know. I need to get better at that. I don't know if there's a way I can get notified of YouTube comments. I haven't been notified of YouTube comments. I don't know if I've gotten any YouTube comments other than the spam comments. I've seen I have 2 spam comments, both in Spanish. Not sure what's going on there. Definitely trying to get us to look at things we shouldn't be looking at. Didn't look like it was anything like the text message I got the other day. That was definitely a phishing scam, trying to get my Amazon login, my Google email login, and my credit card information. That was a fun one to play around with. I talked about that a little bit on the Discord server. So if you're not on the Discord server and you're seeing this video, definitely check out the Discord server. We can be a little quiet from time to time. Like, it's not the most active Discord. It definitely has a small community feel to it, even though we're at 2,500 people. Or 7,200 people, 7,250 people. That's where we're at right now. We got a lot of people on there, but it has a small community feel to it. But questions get answered. It's a lot of fun. We have a lot of fun on there, even if we're a little quiet. All right. Speaking of the Discord, let me just check out what's going on there. Just checking, seeing what's happening. Don't want to fry our brain too much. It's time for a little bit of a break. Just check out the Discord, see what's happening. Maybe there's some good questions on here. It's Matplotlib. I'm not great with Matplotlib and I'm like NumPy. I've not messed with them much. Just scanning through the ones that I think might be. All right. But yeah, if you're watching this video and you're not on the Discord, check out the Discord. It's a pretty cool place. Like I said, it still has that small community feel, even though we're at 7,200 people. It has that small community feel. Like, you can jump into chat, you can jump into the general chat and just start talking, and someone will eventually respond to you and talk back with you and have a conversation with you. Your conversation isn't going to get lost in a huge stream of questions. We've got a nice little help system set up so that everybody can ask their questions. Doesn't get lost in like all the conversation that's happening. It doesn't get lost in 20 different conversations about help questions. And we get a lot of help questions on there. Like, that's where we're active. We get a lot of help questions. And I think a lot of people join the Discord and they see like the main chat isn't like 20 messages a second. And they're like, oh, this is a dead server. And it's like, they're not seeing the 30, 40 help channels that get opened up every day and a half. Like, a lot of questions get asked on there, and most of them get answered. Some of them are a little weird. Some of them are a little tough. Like, they're really deep questions, and they're hard to answer, or no one really knows what's being asked. It's important to be able to communicate what your question is. And if you can't communicate what your question is, you're going to have a hard time getting an answer. That's for certain. And I feel bad sometimes because we just don't know what is being asked, or we just don't know the technology that they're using. And it's like, you might have to reach out to the people on the GitHub repo because the project is kind of niche. The question is kind of niche. Like, it can be hard sometimes to help people with this stuff, especially when we all have our own jobs. We're all volunteers. All right. I'm trying to think if there's something else I want to deal with on this right now. I'm kind of just wanting to step back and think about how I want to architect the code to work with this. Like, I've got the site because like this is going to have a front end. And I know on my other project, it's got an API and it's going to have a front end as well. And I've kind of split that out into its own like API file, and then like I'm going to have a site file with all the routes for that. And I'm trying to think if I want to do something similar here, or if I want to do something different here. So I'm a little bit of a dead end with it. I'm like right at the moment, just because I've got to think about it and think about what are my trade-offs, what are the advantages, the pros and cons of each setup. Like, should I have all my routes in one file? How do I want to do that? And like, one nice thing is Fast API is built on Starlet. And something interesting that I thought about when I first learned about Starlet. Starlet is basically like Flask, but it's async. It's using ASCII rather than WSGI. Those are the two Python standards for building like a web framework as a way for a web server to talk to a Python web framework. So like Flask was built on WSGI. That's the old standard. It's a sync standard. There's no asynchronicity to it. If you want to run things asynchronously, you have to have threading. And it's just a way for the server the server portion of your site to talk to your framework portion of your site, to your actual routes and all that. And then when we got async Python, they created a new standard called ASCII. And Starlet used ASCII to build a Flask-like framework. It feels similar to Flask. It's got its differences, but one thing that I thought was the most interesting about Starlet was that you could literally use a Starlet app on top of another Starlet app, and you could just chain your Starlet apps together, and they would function and they would work. And Fast API has inherited that, so you automatically get this ability to create a bunch of Fast API apps and then mount them onto another Fast API app, and you get one gigantic app. And so it makes it easy to move routes into other files. Flask had to use blueprints to do that. So you couldn't just create a Flask app and then another Flask app and mount the two apps together. You had to create a blueprint, and you could mount that blueprint onto a Flask app. So it wasn't super intuitive from the get-go on from like a beginner, from someone just learning Flask, how you would do that. And then I feel like I never looked at the code for Flask, but I feel like that leads to some duplication of code, since you have to have a lot of similar functions on your blueprint as you do on your Flask app class, because you want your routes on your blueprint to function pretty much the same as they would function on your app. So I just always thought that was a little bit weird, a little bit odd in Flask, and I really liked how Starlet did it, and now I like how Fast API did it. It makes it easy to just be like, all right, I'm building multiple apps and I'm going to put them together, and so the documentation is the same across the board, how they function is exactly the same across the board. I'm just mounting it onto another app, and that's it makes things work in your brain a lot more simply, and there's a lot to be said for that. And so now I'm trying to think about, how do I want to organize all of this? I'm probably going to split it out. I'm probably going to have like an API file, which is going to have all of our API endpoints. So maybe I should do like an API underscore v1.py, and that'll have all of my v1 API routes. And then I'll have like a site or a frontend.py, which will have all of my routes that aren't part of the API, which are part of the front end, which are sending HTML and not sending JSON objects. Because that's what Fast API does by default. It sends a JSON object. Everything gets turned into a JSON object. And it does that in a very intelligent way. And it does it in a way that lets you change that behavior so that you can do more I've not looked at how that actually functions. And because Fast API is built on Starlet, I believe you could literally just mount a Starlet app into Fast API, or mount a Fast API app into a Starlet app, and they should just function. I've not looked into it. I'll be curious when I do look into it. Are they actually just using Fast API for the front end, or are they using Starlet for the front end stuff? I could see it going both ways. The one advantage to using Fast API is Fast API is a little bit more fleshed out, I think. It's like you have this ability to do dependencies on a route and then add your Jwt Bearer. And like you might want to do that for like an account page. So your user, you're ensuring that the user is authenticated and logged in and able to access that. And that's something that's interesting too. We could have the same signature system, the same Jwt Bearer system, but we could modify it and we could say, okay, this is going to be a route that only a user account can access. And so we'll have our token up here. We'll have if I could hit the right buttons, that would really help. Like we might have a bot field and we might do bot true. And then if it's true, we might set up our dependency to have a special validation check to ensure that like our front end pages aren't being accessed by a bot account, and are only being accessed by a user account. Because the bot doesn't need to access HTML pages, so why even render it and send it down to them? So just for performance reasons, you might block a bot user from accessing authenticated pages. So like, there's a lot of things to think about. And then like, not only just what files am I going to put my routes in, how am I going to organize this? What file should this go in? And what file should this go in? And like, if you look through here, he has a few different files. Like he has his API file. He has his auth package where he's putting a bunch of stuff inside the auth package. Then he has his models, which is where he put his schema models inside of there, which is what he used for his routes. So yeah, there's a bunch of different things in here, a bunch of different things to think about. And I think I'm gonna wait till next week to implement anything more. I think this was a good little stream. Didn't get any real. I was busy today. I had work today, and I didn't think to announce the stream yesterday. But my intention is, barring like anything, any life events happening or any holidays where I'm hanging out with the family, I'm planning to every Wednesday at 5 p.m. Eastern Time and every Sunday at 3 p.m. Eastern Time, I will be streaming. And like my Wednesday ones are going to be Q&A times. It's just going to be hanging out, looking at code, a little less formal. And my Sunday stream, that's going to be working on a project. It's going to be a little more planned out, not really looking for questions too much. I'll answer questions if I've got time, for sure. But like that one's going to be actually working on a project and actually building stuff. And I'm going to be getting, like that one, I'm getting a little bit deeper in the weeds of like the actual code. That's why like on that project, I actually built the hashing function. And this one, I'm not so much digging into that. This one, I'm looking more at how do I use packages to do stuff. Like this one, I used Alembic. I'm using Alembic for my database migrations. It was interesting getting that set up. I'm able to generate all of my migrations from my actual SQL Alchemy models. But on the other project that I'm working on Sundays, that one I built an entire database migration system. It's a lot less featureful than Alembic, but it works. And like for that project, it's perfectly fine. That project is purely intended to be run on your own computer, maybe on a computer on your personal network, never exposed to the actual public internet. And So I'm not too worried about security, and I'm not too worried about actual performance and any of that stuff. Whereas with this project, I do intend to publish this project and make it public and make it something that people use. And like I'm working with Moses on the Discord server. We'll see how far we get with that. He built some really cool stuff for like doing syntax highlighting for code on a website using React. So I'm working on a backend that maybe we could hook up to that, and we'll see what happens. But time will tell, and we will hopefully get this project working. So this was a good stream, I think. I think I'm going to cut it off here. I think an hour and a half was pretty good. We got a lot of progress made going through this tutorial, talking about what's going on. And I'm going to think about how I want to organize all of this code for next week. All right. So yeah, that was pretty good. I think that was a good stream. I had a lot of fun. It was interesting stuff, interesting things to talk about. So y'all have a great week. Like I said, if you've got any questions, reach out to me on my Twitter, reach out to me on the beginner.codes Discord server, reach out to me on the comments here. I'm going to figure out how that works, figure out what's going on there, and let me know what's going on. Let me know what questions you have. If there was any questions from this tutorial, like if you're having any issues going through this tutorial, like I said, it's in the description. If you're having any problems with it, if you're not understanding something with it, let me know. If you got any questions with coding, let me know. If you have any questions about your next steps, let me know. Like, I'm available. I'm free. Like, I have the time to do this stuff. I find it fun to do this stuff. So let me know. Any questions, let me know. Y'all have a great day, a great week.